Here you see a field edge affected by spray drift. Now there may be a number of reasons for this. For example, wind current, pressure is too high, operator error, or temperature inversion. One of the best things you can do to help avoid occurrences like this one is to properly calibrate your sprayer. Hi, I'm Mark Miller along with Betsy Kreisel of the Franklin County Weed Board. Today we're going to demonstrate how to properly adjust your boom sprayer for broadcast applications. The process of calibrating a UTV sprayer is essentially the same as calibrating a field or boom sprayer. The tools needed for calibration include the sprayer, a measuring tape, timer, something to collect water in, and a pitcher graduated in ounces. Keep in mind, the more accurate your measurements, the more consistent and accurate your calibration is likely to be. After thoroughly rinsing the tank of any chemicals, fill it with enough water to conduct a few tests. Before calibrating, as well as before each application use, run sprayer at the desired pressure to ensure that everything is functioning properly. Make sure there are no leaks, the filter is clean, and the desired pressure is consistent. Also, that the nozzles are adjusted for overlap and set at the proper angle. For this demonstration, the pressure will be set to 30 pounds per square inch. Refer to nozzle charts for the nozzles being used, as there may be pressure restrictions depending on the various types of herbicides being used. As you can see here, the top gauge is set to spray at 10 pounds per square inch, while the bottom gauge is set to 40. Notice the difference in droplet size. The higher the pressure, the smaller the size of the droplet, and the smaller the droplet size, the more prone it is to drift. After completing inspection and everything is running properly, with the nozzle set to the desired pressure, measure the width of your spray pattern. For this demonstration, the spray pattern will be 35 feet wide. Next, on a flat, even area, measure out and mark a straight 100-foot distance where you will run the spray pattern. Choosing a flat, even surface helps maintain consistent speed for testing purposes. Spray a consistent pattern on the ground over the 100-foot distance at a constant speed and record the time it takes to get to the end. A rate of 3 to 4 miles per hour has proven to be the ideal speed at which to travel when spraying for a nice even coverage over rough terrain. If the speedometer is unreliable or the spray unit being used doesn't have one, try a portable or handheld GPS device to determine the speed. For our demonstration, it took 17 seconds to travel that 100-foot length. The next step is to collect water from each nozzle for the same amount of time it took to travel the 100-foot distance. For this demonstration, we collected a total of 116 ounces. It is important to keep track of the separate amounts from each nozzle in order to determine if there's a difference in their output rates. It is possible that one or more of the nozzles are not working properly. A consistent measurement ensures a more consistent application. For this demonstration, we collected water from 3 separate nozzles. To figure out how many gallons the nozzles put out in 17 seconds, take the total amount of water collected in ounces, 116, and divide that by 128. That's how many ounces there are in 1 gallon. After this calculation, a total of 0.906 gallons was sprayed over the calibration test area. This number must now be converted to gallons per acre. Take the spray width, 35 feet, multiply by the length, 100 feet, to get the area sprayed, 3,500 square feet. Divide that number, 3,500, by the number of square feet in 1 acre, 43,560. This converts the area sprayed into acres. For this demonstration, that area is 0.08035 acres. Then take the gallons sprayed, 0.906, and divide by the acres sprayed, 0.08035, to come up with 11.28 gallons per acre. For a more accurate output rate, it might be a good idea to repeat this entire process several times and take an average. Finally, compare this test rate to the recommended or desired rate. If it's greater than or less than 5% of the desired rate, make the proper adjustments and repeat the test. To find that plus or minus range, simply take the desired rate of 11 gallons per acre and multiply by 5%. Add and subtract that number to the desired rate to find the proper range. So, 11 gallons per acre times 0.05 equals 0.55. That makes the desired range between 10.45 and 11.55 gallons per acre. The demonstration rate of 11.28 gallons per acre falls within those numbers. Therefore, this test is complete and ready to spray. If it's off by more than 5%, fixing the problem may include adjusting the pressure, the speed, or both. For instance, for a higher output rate, slow down the travel speed or increase the nozzle pressure. Conversely, for a lower output rate, increase travel speed or decrease the nozzle pressure. However, keep in mind that calibrating with water is a thinner solution. Thicker solutions like dry flowables or diuron may alter these rates. Repeat this test after any adjustments are made until the actual rate is within a 5% difference of the desired or recommended nozzle rate. Check all nozzles or other vital parts of the sprayer if there's any trouble or issues getting that correct output. As you can see, our numbers show that the test rate is well within the recommended range, so we are ready to spray and utilize our license to kill. Remember, the more accurate and consistent your measurements are, the more accurate and consistent your application rates will be. Work smarter, not harder.